We're beginning a new section of this course where we're talking about power transmission. We looked at engines already, and we talked about at least one way of creating power, mechanical power, from some other energy source. So we looked at liquid fuels to rotating shaft out of an engine. And we could have a lot of different things that create power for us. So it could be an electric motor, it could be a windmill or a water wheel, it could be a lot of different things. Quite often, the things that generate mechanical power or create the power are a rotational source. So a rotating shaft that rotates at a certain speed with a given amount of torque available and so forth. And often we need to do something else with that. So there are different types of power, and that may be a bad term, but at least it's one way to look at it. And so if you see here, I listed 3 different types of power. There's what I call linear power, which is force times velocity. So I got to move something in a certain direction at a certain speed. So, and we'll see hydraulic cylinders and things like that where we need to lift loads or move things around linearly, so translate things. We have the rotational power, which is what we talked about out of the engine, out of other sources. But often we need a different number on it. So we need it to spin faster or slower. So something like that. So we need to get from a high-speed shaft maybe to a low-speed shaft or vice versa. And so we have the rotational power that we need to think about transferring. And we also have a fluid power, which we're going to spend some time looking at. So we can take mechanical power that's rotating and actually translate that into fluid power. So give it some velocity moving through a pipe, have some pressure associated with it, and that'll be a fluid power. So we'll look at all those different kinds, but we always have to ask a question: what is it that I need? So what am I trying to accomplish? What mechanism or machine am I trying to run? Do I need linear motion? Do I need rotary motion? What kind of motion do I need? And what is my source? What do I have? And how do I get from one to the other? And as we transfer power like that, there's a lot of things we need to think about as engineers when we're designing these systems. And I've put a list of them over here, and I want you to keep these in the back of your head as we go through these next several sections of this course. So we want to look at the efficiency of course. So how efficient is it to go from one to another? If I need to speed something up or slow it down, am I losing power in the process? So how efficient is that process? We need to think about flexibility. So can I go around corners or things like that? So if we think about agricultural machinery, often we hook an implement on the back of a tractor, and that tractor has to go through the field, and the tractor will go over hills and around corners, so that implement has to bend either laterally or vertically relative to that tractor. So how do I get the power from the tractor to operate that implement? Maybe some rotating parts or mechanisms or something on that implement. How do I get it from one place to the other? You know, a straight shaft is going to bend and break, so I need to have some flexibility. So how flexible is it? How controllable is it? So can I speed it up and slow it down? So a lot of mechanisms run the same speed all the time, and I'm happy with that, but a lot of things I need to be able to control the speed. I need to be able to control force. I need to be able to control other aspects of that power. So how much control do I have? How easy is it to control it? So I need to look at those aspects of the mechanism that I design. I need to think about longevity. How long is it going to last? Is the customer going to be happy with this, or are they going to be replacing parts periodically? So that's always something in the design process. And we'll see that in a number of things we look at that we design based on longevity. How long is this piece going to last? And so we have an expected time to failure, an expected time that the customer should have to replace this part, and we know that is going to happen. We think about maintenance. So how much is the customer going to have to maintain this thing, and what are the consequences if they don't maintain it? So does it have to have lubrication? Does it have to have cleaning? Does it have to have periodic adjustment or something like that? So those are things that are going to affect how easy it is for the customer to use the product that I create. And then we think about the environment that it has to work in. In agriculture, we have one of the worst environments. A lot of heat, a lot of dust, a lot of cold, so extremes in one way or the other. We're often outside a lot, and so light can be a problem for a lot of materials that we put in these things. Rubbers and things like that tend to degrade with light. availability, and so we have to think about those kind of things. What's the environment that we're putting in? Is it going to operate correctly for a long period of time there? And then ultimately safety. So that'll always come into play in everything that we look at. How safe is this stuff? So as we look at these different power transfer methods, keep all of these things in mind and be thinking about what's the right thing to choose, because a lot of times I can do it a lot of different ways. I could use some different techniques, different types of mechanisms to transfer the power, V-belts versus chains versus a hydraulics, a fluid power versus a lot of. So which one's a and which one is going to be cost effective, which for us. There's a lot of things that decision in terms of what I choose for a certain application. So what we're going to do is a number of different transfer methods, I guess we could call these. We're going to step through these. We'll spend a fair fluid power. We'll look at V-belts and chain drives. We'll go through design processes with those, design those things and what we have to take there. We'll talk about power takeoff drives, a rotating shaft corner, and some limits there. We'll look at overload safety. So what happens if something gets caught or plugged, and what breaks? And so we'll often design a sacrificial element into our drive system so that it's what gives first. It's easy to replace, it's inexpensive, so we don't break something that's expensive and hard to replace. And then we'll look at some couplings and how we connect different rotating parts together if there's some alignment issues. So these are the different topics that we're going to look at. Again, we'll start with the fluid power and spend some time there.